first. Oh, I dropped it first.
Hey, what's up, guys?
We drop our things at the same time, but my coin touched the ground first.
No, my notebook is heavier. Guys, you should know that weight doesn't matter. The thing that matters is that the gravity is the same in both objects.
What?
An experiment about free fall.
How fun! What are we going to do?
We're gonna do an experiment dropping things that had different sizes and shapes, and we're gonna see which one reaches the ground first.
What's free fall?
According to NASA, an object that is moving only because of the action of gravity is said to be free-falling. This means that the acceleration of the free-falling objects can be seen as the gravity itself. Also, the mass, size and shape of the object are not a factor in describing the motion of the object. For example, if you throw a weight and a pencil together, they will reach the floor at the same time, which means that all objects free fall with the same acceleration. We can see this phenomenon in our daily life with falling objects, with the rain, and also if you decide to jump from a plane. This is related to physics.
Let's go to the lab.
I have a hypothesis.
Really? What is it?
Well, the spheres with a bigger height will touch the ground quicker.
First, we will measure the distance from the free fall machine to the sensor. Start with the first sphere. Put it in the free fall machine. Measure the distance. Set the smart timer. Set it in time, 2 gates, and press start. Press the button and the sphere will fall. Write down the result. Do the same process with the second sphere. Then with the other sphere. And finally with the last sphere.
But polar bears have the same gravity as we do?
We'll just have to see.
Gravity is the force of attraction by which terrestrial bodies tend to fall toward the center of the Earth. All bodies have the same gravity, but the force of attraction is different depending on the mass. More mass equal to more force.
The 3 times we did the free fall experiment with the spheres, we realized that the time was different because of the air resistance. Then we got the average of the 3 results. Then we used the distance formula to get the acceleration.
Gravity that polar bears have is different than the gravity that you have, because gravity changes depending in which place you are located. If you get closer to the center of the Earth, gravity will decrease because of the angle. The North Pole and the South Pole have the same gravity because they are aligned.
Conclusion! I learned that in free fall, weight doesn't matter. What matters is the gravity.
Of motion, the shape of the object is gonna influence if the object is gonna break through the air easier or not, reaching the ground at a higher speed.
I also learned that gravity changes depending on what part of the world you are located.
But the best part was
There are hypotheses.
Was true.
To solve the first problem, we use the final velocity formula, and as a free fall, this doesn't have initial velocity. We wrote 0 and then multiply the gravity by 2 and then by the number which indicates the height. divided, you get the square root. Some problem, we just isolate the initial velocity from the original formulas. And in the problem number 3, we did the same thing, but instead of the initial velocity, we isolated deceleration. The fourth problem, we just got the time it took to be in the maximum height, the time, the total time in the air, and the position velocity different times.